Hello everyone, this is back camera guy for you, and this is the continuation of your last video, which is what is light, and this is the part 3 of it. Before we begin, let me explain few terms, and this will help us to explain further. Okay, so first thing is wavelength of a light. Wavelength means, as I have explained, that light is nothing but electromagnetic wave meaning it has two like peaks and two crusts, right? So distance between two peaks is called wavelength, and how quickly it's vibrating, that is called frequency. So like if frequency go high, then your wavelength will be shorter. If the frequency is lower, then wavelength will be broader. Okay, so in that with that understanding, we can say for infrared wavelength is quite higher, for ultraviolet wavelength is quite smaller, and in between we have visible lights. Okay, now with this understanding, let's try to understand what happens when we heat up a normal object, a piece of metal, right? So when you heat up an object with lower temperature, in lower temperature, let's say 200 degree or 300 degree centigrade, it doesn't glow at all. Okay, but it radiates heat. Radiates heat meaning it's actually radiating uh, infrared light. We can see the infrared light in infrared camera, but our eye cannot see that. Now if we increase the temperature further, and let's say we are approaching 1000 degree of centigrade, it will start emitting red light, red glow, right? Red glow meaning, if you try to recall like what we discussed in last video, along with infrared, because it is emitting lot of heat now, it's emitting lot of infrareds, but along with that it is also started radiating some visible length light. For example, red light is shifting little bit towards the left, right, in the spectrum. With further heat, like let's say when it is reaching up to 5000 degrees centigrade, it will radiate white light. Why? What is white light? Meaning it is actually emitting all visible lights, and along with that it will also radiate lot of infrared light as well. So lot of infrared light and all of visible wavelength. Okay, and some ultraviolet light as well, right? So with this understanding, Rayleigh and Jeans, they also knew a fact that the light coming out from a body doesn't depend upon the source of the heat or the kind of material, but the temperature of the material, nothing else but the temperature of the material. So with classical theory, which Newton has given, right, using that Newtonian understanding, they try to explain this emission of light, and what they come up with is kind of absurd. What they come up with is, they're saying with infinite that body should radiate infinite times of infinite energy, and it should radiate lot of ultraviolet, but that doesn't happen. These things, this occurrence, that a theory, the classical theory, is not able to explain what is going on when we heat up an object. These things called is famously known as ultraviolet catastrophe. So it's not a catastrophe by itself, but it tells like what Rayleigh and Jeans finds out, that classical physics is not able to explain what is going on, what would go like if we heat up our object. Now, on the same time, Max Planck, a German physicist, he was also working on a different problem. He was working on a problem where he's trying to find out why heat flows from uh, like more heated area to less heated area. Hotter area to colder area, right? And then what he finds out that When material radiates heat, it radiates in a package. It's a discrete thing, it's not a continuous thing, it's discrete things. Like you can imagine it like it's not like when you want to have a glass of water, you go to the tap, you open the tap, get your water, and stop the tap, right? So discrete packets. That explanation actually solves the ultraviolet catastrophe. And with that understanding, Einstein predicted that, yeah, that means light is not just a wave, it also has a characteristics of particle. That's the reason we see lights in chunks. And yeah, so that is what also known as black body radiation. So what we do with this understanding, we do a lot of things, like the birth of quantum mechanics actually happened from this moment. And also, like when you see stars and the moons, right, based on the glow, right, like for the stars, in case of stars, right, like what how they're glowing, right, the color of their glow, right, tells the temperature, the surface temperature of that star. For example, if you see a star which is glowing red, then we'll know that the surface temperature is lesser. If it is glowing white, let's say for our sun, surface temperature is higher. And if it is in blue, right, more bluish in color, then we'll know that surface temperature is even greater. So meaning, like, based on the color coming out of a body, we can tell the temperature of that body, right, that material. That is one of the, I mean, breakthrough of black body radiation. Okay, see you all in the next video.